Good evening, everyone. I will be discussing to you today about Java collections. Under Java collections, I will only be discussing three things, which will be sets, lists, and maps. But first, I'll discuss to you today about sets. Set is like a bag of objects rather than a list. They are based on the mathematical idea of a set, a grouping of members that can contain zero, one, or many distinct items. So imagine in your bag you would have different books for different subjects. That would make them as distinct items. You would not have two math books that are for one subject. You would only have one math book for one math subject. So in our next slide, that would be duplicate items are not permitted in a set, and a set does not arrange items in order, but the sorted set does. In the second bullet, we cannot add an object at a specific position since the elements are not in any order. So you, can, you cannot add an object to a specific index because all the elements are not in any order. And in the third bullet, we cannot replace an item for the same reason, though we can add one and delete another. In an example, I will show you this one. So I have Arthur, Boateng, and Cristiano. And then the output would be Arthur, Cristiano, Boateng. But what happens if I add, so in the index 1 or index 0, it's Arthur, and in index 1, it's Cristiano, and index 2, it's Boateng. So obviously, if we try to add another name, let's say Balde, you would see this output. Balde is now in index 0, while Arthur is in index 1, Cristiano at index 2, and Boateng at index 3. You cannot add an object at a specific position since the elements are not in any order. What if I were to put, say, 1, index 1, you wouldn't let me because it usually when you put a number before an element, that this one indicates the index where you want it to be placed specifically. But in set, this does not work. As I said in the presentation, elements are not in any order. So about the replacing, you can replace an object instead of having it put in a specific location, specific index. So, for example, hs.remove to remove an object, and then we choose what object to remove, which will be Boateng. So simply we're replacing Boateng with Balde. In the output now, we would see Balde, Arthur, Cristiano. So again, elements are not in any order, as you can see. Retrieving all the items is possible, but the sequence is indeterminate. What do you mean by indeterminate? Retrieving all the items is possible, but the sequence is indeterminate, meaning you can retrieve all the items within your set, but the sequence is always different every time because you'd be adding or removing an element from the set. It is meaningless to find what position an element is in because again, a set keeps like it's not sorted in any way because we keep adding things and removing things from it. So to find what position it is in is very impossible. Well, I mean it's possible, but it's still meaningless because when you when you think of a bag, say a very not organized bag, everything inside would be very very disorganized. If you're an average student, it would be very disorganized. In sets there are also three operations, which are union, intersection, and symmetric difference. So in union, mm, we would have to have another list for this. Set string, say set string HS, and then beneath that would be HS. We're gonna remove all this. Beneath that would be HS add all arrays dot as list new oops sorry new integer no string sorry new string, and then inside the string would be just three elements. Make it simple. Hmm. Ape that and then cat. Then we make another list set string hs2 hs2 equals new hash set string hst dot add all arrays dot as list new string. Now in this string we'll add four elements. We'll add ape for one. Boar boar, and then kitten, and then one more would be dog. Yeah, so we'll add dog. So first off, the first operation we're going to use would be union. In union, what would happen is the list of HS and HST would add together. But again, there would be no duplicate elements. So we would see that right here, right now. Set integer union name equals new hash set, excuse me, sorry, string. I'm forgetting. It's my practice. I was using integers instead of strings. New hash set string. This will be HS. Below that would be union dot add all HST. So what happens now is that string union, string union, this one, is now HS. So what's ever inside here is union. And now union is being added with HST. So what's inside this set of what's the elements inside the set would be added into union, which is again this one. System dot out dot print line. If we put union there, if we click run, we would now get this. Boar, kitten, bat, ape, cat, dog. So we have two apes, but we only got one. So yeah, there are no duplicate items. We got bat, which is from HS, cat from HS, dog and kitten, and also boar from HST. Our next operation would be intersection. Now in intersection, what happens is that you will find the common elements of the two sets and print them out. We name this into intersection. And intersection dot retain all. So right here in the side it says retains only the elements in this set that are contained in the specified collection. In other words, removes from this set all of its elements that are not contained in the specified collection. If the specified collection is also set, this operation effectively modifies this set so that its value is the intersection of two sets. So that's computer programming language, but in English, it's whatever is common, it will print out. So retain all intersection. Oh, sorry. Retain all HST. Because, I'm sorry, forgive me. Intersection is now HS, which is this, and HST hasn't. It's right there. So now when we print this out, intersection, when we print that, you would only give us ape because only ape is common in the two lists. Next is the symmetric difference. So it's gonna give uh, the differences between the two sets, which will be this. This one will be called difference. Now difference dot remove all. What does remove all do? Removes from this set all of its elements that are contained in the specified collection, optional operation. If the specified collection is also a set, this operation effectively modifies this set so that its value is the symmetric set difference of the two sets. So again, that's programming language, but in English, it removes the differences. Differences? Or how would I say that? I'll wait. Let me run it first. HST. Sorry. When you run it, our output would be this. Bat and cat. Why bat and cat? Because in HS we have bat and cat. The difference with HST is that they don't have bat and cat. So HS is finding differences with the set HST. And then the difference with HST is that they don't have bat and cat. Simple as that. And that's it for our sets. On our second part for our collections tutorial video, we will now be tackling this. Now, we have this. I made this to shorten the time length of my video because I have realized it has gone over a bit too long. So right now, if we have list string, the name, list strings, new array list string. So we're adding 1, 2, 3, 4. And then it prints out everything here. We can get the size of the string by doing this int for integer, getting the size, and naming our variable, our list strings dot size. So L size is now list strings dot size, and then we would get to see the size when the system prints it out. Remove 3, 0, 1, 2, 3. This will remove index 4. I mean index 3, which will be removing the string element 4. The string add 2, index 2, 0, 1, 2 at this spot, 8. So 3 will be replaced with 8. Since 4 will be gone, even, hold on, I'll show you. So if we run the code, we have the initial setup, which is 1, 2, 3, 4. Then remove index 3, which is 4. So right now we don't have any 4. And we added 8 in the second index. But if we didn't remove index 3, you would see that 8 is still at index 2, but everything after index 2, which is the elements 3 and 4 are pushed uh, one additional one index from the original index. So that's what happened. And I guess that's all you need to know for this. It's that simple. Adding and moving. This time you can add a element to a specific spot. So if we change this to let's say index 3, we would have that at the place of element 4. And now element 4 is being pushed one index further than its original index. However, if we put index 4, 8 would be in the last index in the list. Oh yeah, and the print size. The size of the list is 4. But if we keep adding, list strings dot add 5, if we keep adding, the list would keep growing. It's that simple, and that's all you need to know about this. Thank you. On to our final and last uh, discussion or topic for collections is maps. So in maps, basically, maps are rather different from lists and sets because instead of storing individual objects, they store pairs of objects. The pair is made up of a key and a value. The key is something which identifies the pair. The value is a piece of information or an object associated with the key. So in a pair, which is this one right here an example, there's always a key and a value. The value of this key would be Peter Baelish. I'm sorry, I don't watch Game of Thrones. I don't know how to pronounce that name. But Peter Baelish. So that's the value of this key. And Peter Baelish is associated with the key 8. And now, if we don't mind this down here, this is I'm going to be using that in a while. So now if we run, our output would be this. 3 is equal to Jon Snow, 4 equals Jaime Lannister, 6 Sansa Stark, and 8 Peter Baelish. Okay, so now I have added one of my examples from down below. If we map put key value 4 and the key 4 and then the value Daryl Dale, it will replace Jaime Lannister with my name. And there you have it. So 4 is now equal to Daryl Dale. So this can be applied to any present key and value. If you can replace them just by doing that. If you click 3, which is Jon Snow, I will be now replacing Jon Snow. Or you can have it 5, so I'm somewhere in the middle. Right there. So since there's no other key of 5, I'm just being added into the map. Okay, on to our second example. Another example. We have string ape. Why ape? If you ask, it's on my group initials for our CC14 group, Abrio, Okolba, and Espancha. Enough sharing. String ape is equal to map get 3. So this is getting the value of 3. So if we print ape, it would give us Jon Snow. Right there. But you can also remove Jon Snow if we put map remove. So when it prints out, we don't need this. When it prints out, Jon Snow will be now gone. Oh, I'm sorry. You can just do it like this. You don't have to put string 8. For example, in size map, this is getting the map size of your map. So in size map equals map.size and print it. You can get the size of your map, which is 4. Now adding a map or removing a map obviously uh, decreases and increases the size of the map. So this one, this checks if the map is empty or isn't. So if we click run, it's false. Boolean is empty equals map dot is empty. So this checks if if the map is empty, and it's not. But however, if we do that, and we run, it's true because there's nothing there. And that would be all for my discussion of sets, lists, and maps. I hope you learned something from my tutorial video. Thank you. That would be all today for my tutorial. Thank you.